I welcome all of you to the day 4 of our online faculty development program on AI and ML and data science for engineering application. So today we have two sessions. In the first session, I'll talk about the data visualization technique and also will implement all the visualization techniques which I am going to cover using R programming. And in the second session, Dr. Dinesh will continue yesterday's discussion related to deep learning and some advancement over the particular field. So data visualization is a very important part of data science. When you are given with a data set, so if you go through the different features of the data set, you may not get a complete idea about that data set. But when you show the data set in the form of some kind of visualization, so that will help you to see that how the data are distributed, or you can say, is there any anomaly in the data set? Is there any missing value in the data set? So these things we can easily find if we go for data visualization technique. So this is the outline of today's 2 hour session. We are going to start with introduction, why data visualization is required. Then we'll go for application of data visualization technique. Then we'll discuss about different types of analysis. Generally, the analysis is based upon how many features you are going to consider for visualization. Somebody can take only one feature, somebody can take two features, and somebody can take more than two features as well. So based upon that, we have different type of analysis. Like if you remember, while we discussed about supervised learning also, especially the nearest neighbor algorithm variants or the efficient algorithms, we consider only one feature. Sometimes we consider both the features. Okay, when you calculate the distance of one data point or one pattern with the test pattern. So that we'll discuss. Then specifically, I am going to discuss about some of the visualization technique, which are pie chart. We'll go for a 2D pie chart, as well as we go for 3D pie chart. Then we'll go for bar chart. Then we go for box plot, which is a very important data visualization technique. Then we'll go for histograms, then light chart, then scatter chart, and at last we are going to discuss about skewness, which is again of two types. One is positive skewness, you can say, and this negative skewness, you can say. So these are the topics that we are going to discuss in today's session. So let us understand what is actually data visualization. Data visualization provides an important suite of tools for identifying a qualitative understanding. So normally we have a qualitative analysis, another is called as quantitative analysis, right? But here it is providing as your tool, like you are simulating something, okay, via using a particular tool. You are writing a code and you check that whether your code follows your expected outcome through a particular tool. So there are different type of tools we have. Not only we have to write the code, but there are some tools are there. If you give your data set as input, then you are going to get the output as different visualization based upon the features. So here we focus on the qualitative understanding. Okay, once it is represented in the form of a graph, or you can say it is chart, we can say that it is easy to visualize. Mostly, if you look into the top level management people, if you talk about a particular company, so they don't want to see the report. Rather than they want everything in the form of a graph. So rather than writing everything in the text, so you have to represent it in the form of different data visualization technique. And data visualization can be helpful when we try to explore the data set and extract some information to know about a data set. Because we know Kaggle is one of the uh, famous source for various data set in research community. Mostly people use these data sets which are openly available. So when you are downloading a new data set, you are not aware a particular data set, so you can go for data visualization technique. So data visualization technique is going to provide you some insights about the data set. Right? You may not get complete information, but at least some information you will get. So data visualization can help with identifying the patterns. It is also going to help you if the data is corrupted or not, or is there any outliers in the data which is very far away from other samples, and other insights also you can find through the data visualization technique. And data visualization can be used to express and identify key relationship in plots and charts that are more helpful to ourselves or different stakeholders of a particular organization than measures of association or significance. So that's why most of the presentations also, rather than showing the different kind of text, so people usually represent in the form of a graphs. Even if we are preparing a presentation with text, nowadays various AI tools are there which will make your presentation more attractive by adding some of the pictures into your text. Now coming to application of data visualization technique, if you want to model a complex event, if it is a simple event, or if you are dealing with very few number of features, then it is easy to understand, right? If somebody can write a report with less number of words, then somebody can understand. But normally, when you go for a complex events, when you go for a very large application in the scientific community or engineering community, so it is difficult. So in that case, what we are going to do, we are going to use the data visualization technique, which will help us to model complex events and visualize a phenomenon that cannot be observed directly, such as weather pattern, medical condition, and mathematical relationship. These are also applications. Like I want to know that is the highest temperature of a particular place over last 20 years. So if you represent in the form of, let's say, a Excel file or a Word file, people may not appreciate, right? But when you represent that particular thing in the form of a chart or by the form of a well-defined graphs, then it will help us to see the weather pattern in which year the temperature uh, severely increases or it is or decreases in a particular season that we can identify. Similarly, in medical also or hospitals nowadays, different handheld devices are there. They are representing the condition of a particular patient in the form of graphs. Similarly, if you want to know the relationship between two variables, like while we were discussing about linear regression and multiple regression, I told you that it is establishing the relationship between the dependent variable and independent variable. So in linear regression case, we saw that how to represent these two variables in the form of a graph. Like we draw a straight line which by using a B-line function, and we show the relationship between a variable x and a variable y. So in that case also data visualization technology works. So not only this list whatever I am showing in this slide, but you can think beyond this. Any research articles also, especially in the simulation part or experimentation part, we specially represent in the form of graphs or line graphs, or you can say bar chart or different kind of charts, which is more appreciated. Now, if you see a informal picture which I have collected, so here you can see when somebody is showing the data in the form of a table, so nobody understand, right? Although this table is having only five columns and 10 rows, but understanding the entire data is very difficult. But when the same thing I am representing in the form of a bar graph, or you can say histogram, then everybody appreciate it. Okay, so we go for different kind of visualization technique. Now coming to different types of analysis. So basically, we have here uh, dif- uh, we have different type of analysis like univariate analysis, bivariate analysis, and multivariate analysis. So there are three different types of analysis for data visualization technique. So univariate means in a particular data set, you are considering only one feature to analyze almost all of its properties. Okay, you consider like we have seen the dependency between two different variable. Okay, whether they are related or not related, or sometimes we can say positively correlated or negatively correlated. So after that, you decided that there is only one feature. That feature I am going to use to analyze all the properties of the data sets. Right? Maybe that is one of the influencing feature in comparison to other feature. So as you are dealing with only one feature, we call that as a univariate analysis. Okay, but sometimes we need like if you say there is a data point in a two-dimensional, so there is a x coordinate and there is a y coordinate. So in that case, we deal with two features. Or when you go for a three-dimensional graph, we have a x coordinate and y coordinate and z coordinate. So there we are going for multivariate analysis. So bivariate analysis means when we compare the data between exactly two features, then we call that as a bivariate analysis. But when you are exceeding the two features, strictly greater than two features, we call that as a multivariate analysis. So when you are going to represent your data in the form of any data visualization technique, first you need to identify how many features you want to show. Okay, you want to show a single feature, then go for univariate analysis data visualization techniques. If it is two feature, go for bivariate. If it is more than two feature, then you go for multivariate one. Now, coming to univariate analysis, under univariate analysis, we have a plot that is called as box and whisker plot. That takes only one feature. Okay, that we'll see. And on the other hand, when you go for bivariate analysis, we deal with the two features. Like if you go for lines plot, or you go for bar plot, or you go for scatter plot, these all are belongs to the bivariate analysis. So what we'll do, we'll go for one by one data visualization technique, and we'll implement these using R. So let us start with the first one. As I said, first we'll go for the pie chart, then we'll go for the bar chart, then box plot, then histogram, then line chart, then scatter plots, and then skewness. So total 7 data visualization techniques I will tell you using R. Although it is not the complete one, you can explore other data visualization technique based upon what other researchers have used in their article, or what you want to visualize in your research article, or when you deal with a new data set. Based upon the requirement, you can go for it. Okay, but I'll tell you the seven different visualization technique and their variants also. Like I mentioned that pie chart case, we will go for a two-dimensional pie chart. Also, we will go for a three-dimensional pie chart. Both will see. Similarly, every plot case, I'll show you plot or chart case. I'll just tell you some of the variants so that you will understand that how you can represent your data in the form of different graphs, right? So let us go for the first one, that is called as pie chart. So every chart is having some predefined functions. Like in pie chart, you can see there is a predefined function called pi. Okay, and there is a different type of optional parameters, and there are some mandatory parameters as well. Like here, I am showing you 6 different parameters, but not necessary that you will use all the 6 parameters. You may use 2 parameter, You may use only compulsory parameter. Some of the optional parameter you are not using, right? So here, if you see, the first parameter is called as x. So x is obviously required, right? X is a vector used in the pie chart. So you have to declare a vector. And I told you in the previous lecture in what way you are going to declare a vector. For vector in R, we have a predefined function called C. Okay. Using C function, we are going to declare a vector in the pie chart. Then we have labels. Labels is used to give description to the slices. So pie chart means what? There is a circle, I can say, 360-degree circle. Then you are going to partition the pie chart into multiple pieces, right? Or multiple slices. So every slice is having some level. So that level you can specify using the second parameter, that is called as levels, which is going to provide you the description of a particular slice. Then we have radius. So radius indicates the radius of the circles of the pie chart. So we generally take radius in between -1 to +1. Then we have main. Main indicates the title of the chart, which is optional. If you want to put, then it is going to show you a name of the chart, or you can say title of the chart at the top. And COLs indicates the color which you want to give. You can mention all well-defined colors like blue, green, red, or any color you like. And then we have a clockwise. Clockwise is a logical value. Logical value means the value is either 0 or 1. Okay. So it is indicating if the slice are drawn clockwise or anti-clockwise. So when you take a pie chart, suppose you are taking XYZ. So whether you take XYZ clockwise or anti-clockwise, based upon that, we are going to draw the pie chart. Okay. So now I request all of you to please open R. Then we'll write a simple code to show how to draw the pie chart. So let me open R Studio in my computer system. So I hope all of you have installed, because in the previous lecture we saw different regression techniques. So once R Studio is ready, I am going to show you a simple code for pie chart. Okay, let me close the old files. Okay, now you know what is console. You can clear the console by pressing Ctrl plus L. Okay, for every chart, let us create a new file. So I'll go to File, New File, then R script. Okay, so let me save this chart in our material folder. Okay, I'll go to material folder so that you can download everything from material folder. So I'm writing pi underscore chart. Okay, so I have created pi underscore chart is a file, script file, and extension is .r. For example, if you want to go for pie chart, as I mentioned, we'll use a function called pi, right? And pi takes one vector, right? In order to declare a vector, you know I am going to use C function. Okay, C function is used to create a vector, and some values you can write, like I'm writing 21, 62, 10, and 53. That means I am going to show you the four parts in the pie chart. That's why I'm writing four values. So if you need more, then you can increase the number of values. So let us save this in a variable. Let's say let it be x. Then I also mention another vector where I'm going to tell you what is the meaning of this 21, 62, 10, and 53. So what I'll do, let me write, let's say London. Then I can write New York is another city name. Singapore is another city name. and Mumbai is another city name. Okay, and let us save this with a variable, this vector with a variable that is called as levels. Okay, so for pie chart, we need two parameters at least. One is x value, another is you have to show the levels. Otherwise, nobody can understand that what is the meaning of 21, 62, 10, and 53. So I can tell that these are nothing but, let's say, number of population. Okay, in millions or billions, something I can say, right? So now I want to represent it in a pie chart. So I told you in previous lecture, if you want to create a chart, okay, or a graph, so what you have to do, you have to create a chart file. In order to create a chart file, you will use PNG function. So whether you need a JPG image or you need a PNG image or any image extension, whatever you know, so you have to write PNG function. So I can write PNG. Let's say I'm writing file is equal to, suppose I'm writing city.jpg. Okay. For all type of visualization technique using R, you will use PNG function. Inside PNG function, you will write a file name. By writing file is equal to that file name in double quote. And in order to save this file, you have to write dev.off. Dev is used to save the file. Okay. Third line, I have used PNG to create a file. And fifth one, I am using dev to save a file. Then I am writing pi is a function. You can see it is also showing all the parameters of the pi, both compulsory and optional parameters. So in which I want to write x and level, x and levels, x and levels, right? So I told you the default directory where these files are going to be stored is your document folder. So let me go to my document folder, and you can see there is no image here, right? I have deleted my previous image which we created in the previous lecture. Now though there is no image, so when you execute it, then you will see in your document folder, document is a default folder, right? So when I say execute, that is I'm changing it source with echo. In at a time it will execute. Now once it is executed, you can see you will get city.jpg file in your document folder. So if I open that city.jpg file, so you'll get a image like this. What it indicates? So you can see I have taken four values. One is 21, 62, 10, and 53. Okay, which represents London. London is 21. You can see this area is 21. Okay, and Newark, it is 62, which is highest among all. And Singapore is having 10, and Mumbai is having 53. Okay, so you can see we have created a pie chart. In the pie chart, what we did, we have mentioned the different levels. Levels indicates the cities, and there, let's say, population in billions. Okay, so it is a simple one to create the pie chart. And you can also mention, if you want to mention, let's say, if I want to specify what is the chart name, so that I can mention by writing main. Okay, if I want to mention main is equal to something in addition to this x and levels, so in this chart you will get a name, right? Okay, apart from that, if you want some other color, like it is coming a default color, right? I have not mentioned any color in my code, so it is creating the color is for the default option. But we have a very famous color that is called as rainbow colors. In rainbow color, we have a red, orange, yellow, green, blue, indigo, and violet. Right. So these are seven colors. So if you want rainbow color also, you can use a specific function which is called as rainbow to show the pie chart using rainbow color. So let us do that one first. Okay, let me share this code in the chat box. So if you are interested, you can try if you have installed RStudio. Okay, so now I'm creating another file. Okay, and let me save this file as py chart one dot. Okay, now dot r it will save. Okay, so let me take the same x and same level which I have created. Okay, let me copy this one. Then after this, I am creating a chat file. You know, for creating chat file, I have to use png function, and I can write file is equal to, let it be city underscore title underscore colors. Okay, colors dot jpg. So by the name, I just want to tell you, it is not only showing the city and their population, but it is also going to show you the title, and it is also going to show you the colors, right? So for that, I have to use pi. Earlier we have used pi x comma levels, but now additional parameters you have to write. For example, I am writing main is equal to whatever you want to give the title of the chat that you can mention. For example, I am writing city pi chart. Okay, and color is equal to rainbow, rainbow, length of x. Color is equal to rainbow length of x. Why I am taking length of x? So color is going to be taken based upon the length of x. What is the length of x here? The length of x is equal to 4. So you can type here if you want length of x, because x we already created. So it is showing length of x is 4. So it is going to take 4 colors from rainbow, right? Then after this, I am going to save my file. For that, I am writing dev. Dev is always used to save the file. So let me close the previous file, and you can see here there is a city image. I am giving another name here so that when we create a second image, it is not going to replace my first image. Okay, so when I execute it, you can see there is a file created here, name city underscore title underscore colors dot jpg. And if I open this particular file, now my pie chart is showing a title. The title name is city pie chart, and it is also showing the same thing: New York, London, Mumbai, and Singapore, and their population. But this color is given in the rainbow color. Okay, it is given as the rainbow color. Okay, so in this way, you can assign a particular color, and you can specify the chart name in pie chart. But the problem is here that I just want to know by looking into this chart, although I understood that New York and Mumbai is more population than Singapore and London, right? But how much percent they are covering, that we are not able to guess, right? For that you need calculation. You have to take 21, 62, 10, and 53, and you have to do manual calculation. But what I want the pi percentage. Pi percentage means the area covered in the pie chart out of 100, that need to be displayed in my output screen, so that I can understand uh, what is the population out of 100 in these four different cities, right? So for that, let me create another chart. So I am creating new file R script. Okay, I am again taking the same data. That's why I'm copying this to line, and let me save this file as pie chart 2.r. Okay, is the default extension. Then what I'll do, I will calculate the pi percentage. Okay, how to calculate pi percent? I am taking a variable. Anything you can write. I am writing pi percent is equal to round off, because some points it is going to come. So it is going to round that 100 multiplied x divided by sum of x comma 1. What is the meaning of this one? It says that you take a x value, you put here. The sum of these x value. So I think it is 21 plus 62, it is 83, plus 10, 93. Okay. Then plus 53, I think it is 146, if I am correct. So it is taking 146 and normalizing these values in the range of 0 to 100 or within 100, right? So we are writing 100 into x, that means 100 into 21 divided by 146. Okay. So if there is any value, then it is going to round it, right? So that is going to calculate the pi percent. So let me create a chart file here. So png file is equal to, let's say I'm giving the name city underscore percentage underscore legends dot jpg. So we are going to show you the percentage. Here I am going to show you the percentage, means how much percentage it is covered in the pie chart. And also it is going to show you a legend. Legend means which color indicates which city. That also it is going to show you either in the left corner or right corner. Okay, or it is in the top or in the bottom, right? So let us create the pie chart. So for that I'm writing pie, I'm giving x, I'm giving levels is equal to, instead of showing that levels is equal to like here I mentioned London, New York, Singapore and Mumbai, here I am saying level percent you should take is 5%. Okay, I'm not going to show you the the pi levels as London, New York, Singapore, Mumbai, rather than I want to show 5%. Then main is equal to, suppose I want to give the chart name as city pi chart. Let's say the color I am keeping as it is. Color is equal to, I want to take rainbow color length of x. Okay, the length of x is 4, so it is going to take 4 rainbow color. Now I want to create a legend, so I am writing legend. Legend should be available in one of the corner generally. So I can mention legend should be displayed in the top right corner. You can make top left also. Then what we are going to show in the top right corner, I am going to show you London. Okay, I am going to show you another city, Newark, another city, let's say Newark, another city, let it be Singapore, another city, let's say Mumbai. Okay, so these are the cities just I want to show. And I am using another parameter here. Let it be cx is equal to 0.8. I'll show you what is the meaning of this one. Fill is equal to, so let me put enter here so that it will continue from here. Fill is equal to rainbow length of x. Okay. So cx, what is the meaning of cx here? Cx is a, I can say cx number. Like here I am showing 0.8, indicating that the amount by which the plotting text and symbol should be scaled relative to the default. For example, if I am writing 0.8, it indicates it is 80%. Okay, one is the default one, but if you want to, let's say more, then you will write 1.5. If you want small, then it is you will write 0 point something. So it is 80% smaller, right? And in order to save any chart, we are writing the above. Okay, we are writing debug. So if I execute this code, okay, you can see in your document folder, you have another chat that is called as city underscore percentage underscore legends. So if I open that particular chart, again I am able to see a rainbow color. The name of the chart is city pie chart, but here it is not showing the city name, rather than it is showing the pie percentage. That means it is showing here 42 point. Okay, it is going to show you the different percentage. Like here it is showing 42.5%. It is 36.3%. So if I show this graph and I'll ask you whether this person is larger than this person or vice versa. So making a conclusion is difficult, right? But now by looking into this percentage, you can say 42.5% is greater than 36.3%. Okay, but now you may ask me a question here, that which color indicates what? So for that, I have written this particular line, that is legend line. So legend is now available in top right corner. It is showing London, New York, Singapore, and Mumbai, and it is showing different colors. Okay, is for the rainbow colors. So for that, we have written this particular line. Okay, so if I make it, let's say, let me change the CX value to 1.8. Let us see what it is going to come. If I make it side by side, you can understand in a more better way. Okay, so if I execute it, so you can see the updated chart. Let me open the updated chart. So you can see it is little bit larger, right? So 1.8 means I can say 180%. So that's why you can see legend and this chart is overlapping with each other. So in order to avoid that, I have used the CX value is 0.8. Okay. So in this way, you can implement the pie chart. So I have shown you three variants of pie chart. We are left with one more variant. So that is called as 3D pie chart. Okay. So in order to go for 3D pie chart, let me create a file and save this file as uh, pie chart 3. Okay. 3 indicates 3D pie chart, let's say. Okay. So in order to execute your code for 3D pie chart in R, there are some libraries are there, right? Like in previous lecture, we have seen that some predefined data sets, means when you install R, some pre data sets are available. Like we have, I can say empty car data set we discussed, RABREX data set we have discussed. So similarly, there are some libraries and datasets readily available or inbuilt it is available in R. But there are some packages that are not available. So for that, you need to install it. So here in bottom right, you can see there is a package. So it is showing there are different type of packages. Okay, if you want to this package, simply you select a particular package, and if you click install, so it is going to install that particular package. For example, I am writing ggplot2 is a package also used for data visualization. So if I click install, okay, it is asking, sir, do you want to restart R prior to install? Okay, so let's say yes. So it is going to install that particular package. Okay, this is one way you can install the particular package. Otherwise, you can download that particular package, right? You can search in your local directory and you can download it if it is available. Otherwise, you can download and install it. The best way is that here the set of packages are there. So if you need any particular package, simply select it. It is going to install. Okay. So once the package is installed, then only you can include as a library. So for 3D pie chart, we have a library that we need to include to run our code. So the library name is called as Plotrix. So in order to include that, I can write library within bracket Plotrix. Okay, library Plotrix. So when I execute it, suppose I am getting an error, that means Plotrix package is not installed. So I can search the package also here. I can write Plotrix. So you can see it is showing Plotrix package. Okay, if the Plotrix package is not there, you can simply click update if you want to update the package, or if you want to, okay, you can select what you want to update. Okay, you can see the install version for this particular package is also showing, and what is the current available version of the package, that is also shown. Right, so based upon your requirement you can select it, right, and you can install it, right. So in my system Plotrix is there. So if you are new to R, so when you install R Studio, you need to install it in the very first time. Once it is installed, it will not going to ask you. So now I am taking the same data, x is equal to c of 21, 62, 10, 53, and I am also mentioning the levels. Okay. So now what I'll do, I'll create another chart file. I'm mentioning file is equal to, let's say I am mentioning 3D underscore pi underscore chart. Let's say .jpg. So I want this file to be created, and for a 3D pie chart, we have a function called pi3d. There I can mention x, okay, and you have to mention levels is equal to levels, comma, you can mention explode. Explode is if you increase the explode, the slices of the pie chart is going to be little bit far. If explode is less, they are close to each other. And that, let's say the name of the chart is pie chart of countries. Okay. Then in order to save the file, I can write dev. Okay. So if I execute this one, then you can see this is my 3D pie chart. So you can see the name of the chart we mentioned, that is pie chart for countries, and it is showing four different countries and their, let's say, population. And when you increase this explode is 0.1, right? So when I increase the explode to, let's say, 0.3, when I execute this one, then you can see the values are the slices of the pie charts are separated from each other. So if you choose a higher value, they are more separated. Right, here you can see. When I change it to 0.3, they are more separated. So if you choose a more, they are separated more. Right. So based upon your requirement, you are going to select these values. Yeah, it is not showing the Plotrix package. So what you can do, you can write, you can search Plotrix here. Okay, you can type Plotrix. You can see in the third tab you have packages. So there you can write Plotrix. So it will show Plotrix. Simply click a tick mark, check it, and click install. Otherwise, you can write a line install dot packages. Okay, within double quote, you can write Plotrix. So if it is correct, then it is going to install it. Okay, let me say yes. So it is installing the Plotrix package. Just add this particular line. Okay, now Plotrix package is successfully installed in my system. Earlier it was there in my system. Okay, so just the updated version is added updated version is uh, installed in my system. So you can try this line. Are you still getting error? After writing this line, you execute it, and I think the problem is going to be solved. Yeah, you can try and let me know. Okay, it requires little bit time and you need internet, right? Without internet, it is not possible. But once a package is installed in your system, the next time onwards, you don't need to again install that particular package. Okay, so this is all about the fast data visualization technique, that is pie chart. Okay, let us heading towards the next data visualization technique, that is called as bar chart. So we'll discuss the theoretical part, then I'll show you this one. Yes. So for bar chart, we have a predefined function that is called as bar plot, where you have to take a vector. Previously, we have taken x is a vector. Here I am taking another variable as a vector. You can take x also, no issue. So here, as I am taking h, which is a vector, or you can say matrix, okay, and containing numerical values used in the bar chart. And x lab is the level of x-axis, y lab is the level of y-axis. For bar plot, you need two features. One is x level, another is y level. And main is the title of the bar chart. If you want to mention any chart name, that you can mention under main. And there is another parameter called names.arg. So is a vector of names appearing under each bar. Names.arg is a vector of names appearing under each bar. Okay, because we need to specify something, right? So that specification you can mention using this particular parameter. And COL is used to give colors to the bars in the graph. So let us directly do the same thing in the using R programming. So let me close these files. Okay. So now I'll create a blank script. Okay. And save that script as bar underscore chart. Okay. So let me take h is equal to, you can take any variable. I am taking a vector. Let's say the vector is 7, 12, 28, 3, and 41. Okay. I am taking some values. Then in order to create a chart, I am using PNG function. PNG, I am mentioning, let's say file name is equal to bar chart dot png. Okay, then I'm writing bar plot of h. Okay, so based upon this value, it is going to draw the bar plot, and def of we are using to save the chart. So if you execute it, then you will get a bar chart.png chart file in your document directory. You can see here. Okay, so here you can see it is showing 5 different bars. First bar is 7, second bar is 12, third bar is 28, fourth bar is 3, and fifth bar is 41. So although you are not specifying the x level in the bar plot is taken as 1, 2, 3, 4, 5. So it requires x-axis as well as y-axis. By default, the x-axis is taken as 1, 2, 3, 4, 5. And y-axis are taken based upon your input value. Similarly, if you want to color the chart, right? Or if you want to mention, let's say what this bar indicates. Let's say these bars are indicating different months. Okay, that also you can do. And if you want to give a name to this bar chart, that also you can do. So let us do that one. So I'll create a new file and let me save this file as barchart1.r. So I'll take the same thing, whatever I have mentioned here. Let me copy this one. Okay, so here I have mentioned h. H is a vector. I am taking another vector, let's say m is equal to, I want to specify what is the meaning of 7, 12, 28, 3 and 41. So let's say I can say 7 is the sales that that happens in the month of March. Okay, in some unit. Okay, this is for April. Next one is for May. Then it is for June. Then it is for, I can say, July. Right, March, April, May, June, July. Okay, I am assuming that these are the different months or the values indicates, let's say cell or something like that. Okay, so let me change the file name to bar chart months. It is going to show months and it is also going to show you the revenue. So in the bar chart, instead of showing only h, I am showing you additional parameter, that is names dot argument is equal to m. Okay, so it is going to show you March, April, May, June, July, different months name. Then let's say I want to show the meaning of X level, which is month, the meaning of Y level, let it be a revenue. Okay, and you can mention the color of the bar. For example, I am mentioning it is blue color. And if you want to mention the name of the bar plot, you can write main is equal to any name. For example, I am giving here a revenue chart. And if you want to specify some border color also, you can write border is equal to some particular color. For example, I am representing red color. Okay, so what we have added in comparison to the previous one, I have added the list of months. Okay, and I am considering these months using another parameter, that is names dot arg, names argument, and I am mentioning what is the X level meaning, what is the Y level meaning, and mentioning the color of the bars and the border. Border means the outer part of the bar, each bars. So it should be represented in some color. So which I mentioned here, the red color. So if you execute it, then here you can see it is showing you bar chart. So here you can see. So the x-axis represent March, April, May, June, July. So that is nothing but the months. Y-axis represents the revenue in each and every month in some unit. Okay, and the bar colors are given as blue color, and the outer part is represented in red color. Okay, so in this way you can represent the bar chart. Is it okay? If anyone having any question, you can ask. So there is no need of package for this one. All the packages, there is no specific package used here, like Plotrix package in 3D pie chart. So there is no specific package you need to install. Okay, if it is clear to you, we'll go for the last variant of the bar chart. So I'm creating another file, and let me save this file in name. Let's say bar chart 2.r. So what we'll do in this version, I'm going to show you a group bar chart, or we call that as a stacked bar chart. So what is the meaning of group bar chart and stacked bar chart? That indicates that one bar is above another bar, or you can say a bar is splitted into different sub parts where each and every part represents something, right? So for that, for example, I am taking the same example. Let us take months is equal to, I want to consider some months. Let it be, I am considering March, April is another month, May is another month, June is another month, and July is another month. Okay, I am taking a vector and I'm storing that vector in months. And I want to also show, let's say, the sales of different regions. Let it be, I want to consider some regions like East region. Okay, I want to select something as West region, and I want to specify another region, let's say North region. Like that, you can mention any number of regions. And if you want specific color to these regions, that also you can mention. For example, I can write colors is equal to, it should represent each region with a color. For example, I am representing red, okay, green, and let's say blue. These are the three colors I have selected here. Okay, so I have taken three different vectors. One is for month, I have taken months, and in order to show different regions, I have taken regions and different colors. Now we need to enter the revenues or sales, whatever may be. So for that, in R there is a predefined function called matrix. Okay, you all of us know what is the meaning of matrix. Okay, matrix is nothing but a set of rows and set of columns. So if you want to declare a matrix, so here you can use the C function. For example, in the C function, I'm writing 2, 9, 3, 11, 9, 4, some random values, 8, 7, 3, let's say 12, 5, 2, 8, 10, and 11. So you can see here I am taking 3, 3, 6, 3, 9, 3, 12, and 3, 15. 15 values I am writing. So you need to mention how many rows you have here. So I am writing n rows is 3 and n column is equal to 5. Number of rows is equal to 3 and number of column is equal to 5. And by row is equal to true. It indicates that, when we represent a matrix, either we can read the matrix row wise or we can read the matrix column wise. So by row is true means I'm going to read the matrix in the row wise. And you have to mention the number of rows and number of columns. At least one of the parameters you have to mention. Otherwise, it is difficult to determine what is the dimension of the matrix. So let me save these values in another variable that is called as values. Okay, values. Okay. So now I'll create a chart file. So for chart file, you have to write PNG. Suppose I am writing the file name is bar chart underscore, let's say stacked dot jpg. Okay, and I can use the bar plot function. Okay, we have previously also used this bar plot function. So in the bar plot function, I'll supply the values. Values is nothing but a matrix. Okay, then let me write the title of the chart is total revenue. Then names.arg is months, and let's say x level is equal to month and y level is equal to revenue. Then let's say color I'm mentioning is whatever colors I mentioned, that is red, green, and blue. Okay, so I have to also mention legend. The legend I want to display in top right corner. Okay, top right or top left you can write based upon your requirement. Then it is going to show you the regions. Regions is east, west, and north. Then Cx I already told you it is 1.3. Let's say I am taking, and fill is equal to colors. Okay. So bar plot I have used, and I have used the legend to show which color represents what, right? So I am storing it with dev function. So if I execute it, then if I open my document folder, we have a bar chart which is stacked in nature. Okay, so it is overlapping. You can see the last bar and this legend is overlapping. So what I can do, instead of top right, I can write top left. So this one is going to come in top left. Okay. So now it is coming in the top left. So here you can see x-axis represent the month, y-axis represent the revenue, and all the bars are divided into some portions where red indicates east and this green color indicates west and blue color represents the north. So you can see one sale or one revenue is above another revenue, right? One June revenue is above another revenue. So you can see that what is the total sale of a particular company. For example, a company is situated in east, west as well as north. So as a company manager, suppose you want to know what is the sale in our country. So you can use this particular chart. Okay. So now this is all about the bar chart. So if you have any question, you can ask. Otherwise, I'll start the next plot that is called as box plot. Okay, so I think there is no question. So let me show you the box plot. Yeah. So I told you in my previous lecture also, while we discussed about regression techniques, I told you there is a 5-number summary. So 5-number summary means it is going to show you different quartiles and minimum value and maximum value. So 5-number summary starts with the minimum value, then quartile 1, then quartile 2, which is median, then quartile 3. Okay. Then it is showing to maximum value. For example, you are given with a data set with only one feature. So that is, let's say 2, 6, 7, 8, 8, 11, 12, 13, 14, 15, 22, and 23. So let's say this data set is given to you. And let's say I'm arranging these data values, okay, the values in the increasing order. So how many values are there here? If you can count these values, the total number of element is 12. Okay. And all of us know that how to calculate the median. Median is mid value. So if there are 12 elements, 5 element if you make one side, another 5 element in another side, so only 2 elements left. So these 2 elements are based upon their average value, we are going to determine the median. But if this number of element is odd, then you can easily identify because there is only one element. There is no need to calculate the average. So in this case, average is 11 plus 12 divided by 2. So we are getting it is 11.5. Now, as there are 12 elements, I can separate these into one part, that is like this: 2, 6, 7, 8, 8, 11. This is one part. Another part is 12, 13, 14, 15, 22, 23 is another part. So suppose as I have divided the data into two different parts. So in this part, if you calculate the median, so again you have 6 elements, 2 elements in the left, 2 elements in the right. If I say, then it is the average of these two elements. That is 7 plus 8 divided by 2. So that is 7.5. Similarly, in this case, 2 element left side, 2 element right side. So in between you have only 2 elements. So 14 plus 15 divided by 2. So you will get 14.5. Okay, so this is the whole data set, right? And I partition it into two different parts. So if I take the whole data set, so my median is 11.5. But if I take left part, my median is 7.5 and right part it is 14.5. So this is represented as Q2 and this one is represented as Q1 and this one is represented as Q3. And in this data set, the minimum value is 2 and maximum value is 23. So the 5 number summary is 2, that is the minimum value. 7.5 is our quartile 1. 11.5 is the quartile 2. 14.5 is the quartile 3. And 23 is the maximum value, which we can represent like this. So here you can see the red colored dots indicates the different numbers. So this is my minimum value and this one is my quartile 1, quartile 2, quartile 3 and this is my maximum value. But in the data set, why we are doing actually box plot, the reason behind going for box plot is that in our data set there are some outliers. So we can easily identify the outliers using box plot. So how we can do for this? You can calculate interquartile range. So if a outlier, we can say outlier is a data value which is very far away from the quartiles. So if you see the left part, we have quartile 1. So it is much less than the quartile 1. So if you go for right part, it is quartile 3. It is much greater than the quartile 3. So it is designated as an outlier. So an outlier is a number which is less than quartile 1 or greater than quartile 3 by more than 1.5 times of IQR. So interquartile range is calculated as Q3 minus Q1. So in the previous case, if you see Q3 minus Q1, if you calculate Q3 minus Q1, Q3 is 14.5 and Q1 is 7.5. Okay, so if you find this difference, it is you will get 7, right? You will get 7. And I told you 1.5 times of IQR. So 1.5 times of IQR means 1.5 into 7. So you will get 10.5. Okay. So outlier is a number if it is Q1 minus this 1 point times of QR, that is 10.5. Or on the other hand, I can say Q3 plus 10.5. So Q1 is 7.5. So 7.5 minus 10.5, which is minus 3.5. Q3 is my 14.5 plus 10.5. That means it is 25. So if any value lies after 25 or before minus 3.5 is considered as an outlier. So in this case, none of the value lies means that they are away or they are away from quartile 1 and quartile 3. So we are not able to find any outlier. Means there is no outlier in our data set. But if you take this example, like here, I am taking the number of elements is 15. If number of elements is 15, so 7 elements you can take in left, 7 elements you can take in right. So there is a intermediate element. So which I am considering as 15. So 7 elements are there in left, 7 elements is there in the right. So in between we have only one element that we consider as median. Okay. So you can see these are the 7 elements in the left, these are the 7 elements in the right. Now, if I consider only this left element and if I find again the median, so median will come 46. Again, the mid value, 7 values are there means 3 values left, 3 values right, and intermediate value is 46. So that is my median. That is quartile 1. Similarly, if you go for the right part, 52, 53, 55, 56, 58, 75, and 102. So the mid value is 56. So that is considered as my median. Okay, median of this particular data set. So I got this one is my quartile 1, this one is my quartile 2, and this one is my quartile 3. Okay. Now, if I calculate IQR, so I told you IQR is nothing but Q3 minus Q1. So Q3 is here 56 minus Q1 is 46, so it is 10. And I need to find 1.5 times of IQR. 1.5 times of IQR means it is 15. Okay, 1.5 times of IQR means it is 15. So if any value lies Q1 minus 15 or Q3 plus 15. Q1 minus 15 means Q1 is 46 minus 15. So it is 31. Or Q3 plus 15 means, okay, Q3 minus 15 means Q3 value is 56 plus 15. So you will get the value is 71. So if any value uh, lies less than 31, is there any value? Yes, there is a less than one value is there. Or greater than 71, is there any value? Yes, two values are there. So they are considered as an outlier. Okay. So if I represent in box plot, you can see this I am considering as outlier because these values lies Q1 minus 1.5 times of IQR or Q3 minus Q3 plus, not minus, plus 1.5 times of IQR. Okay, so in this way I have concluded that there is three outlier in the data set. So we need to discard this value and we consider the minimum value is 40 and maximum value is 58. Okay. So now for this, we have a predefined function in R that is called as box plot. Okay. So box plot takes X data, notch is a logical value, which is true or false, or 0 or 1 you can say. Then we are showing the bar width, which is also a logical value. And it is true to draw the width of the box proportional to the sample size. I'll show you this with an example. And names are the group levels and main is the title of the graph. So let us see how to implement the box plot. So what I can do for implementing box plot. So let me create a file box underscore plot. Okay. So here, in order to use the box plot, in my last lecture, we discussed about a dataset called empty car dataset. We use this dataset empty cars, which is readily available in our environment uh, to do certain tasks. So, for example, in this case, we are creating a basic box plot. So, I am going to use that particular dataset. So, I am going to take empty cars dataset. In empty car dataset, I am interested in all rows, but I am interested in only two columns. One is MPG, another is CYL. Okay, one is MPG, another CYL. That I want to take from the data set and put in another variable that is called as input. And I can print the head of input. If you want to see the first 6 rows of the data set, then you can write like this. So it is showing you the first 6 rows of the data set where it is showing MPG, miles per gallon, and it is showing CYL. So miles of gallon is a you can say numeric value. CYL is a categorical variable where the values are either 4 or 6 or 8. So in this case, suppose I want to go for box plot. What I'll do, I'll write PNG. Then let's say I'm taking file is equal to box plot dot PNG. Okay. Then for box plot, we have a predefined function box plot. In box plot, I want to do MPG is a function of CYL. So you have to write MPG tilde character CYL, comma, data is equal to empty cars. Okay. Then X level is equal to number of cylinders. Okay. Any caption you can give. Suppose I'm writing Y level is equal to let's say miles per gallon, or you can write MPG. Okay, and Name of the chart is suppose mileage data. And in order to save this file, let's say I'm writing dev. Okay. So this box plot is going to show you mpg is a function of CYM. Okay. So you will get three box plot here. In this box plot, you will get number of cylinder is either x-axis you are taking number of cylinder, and number of cylinder is either 4 or 6 or 8, right or not? Number of cylinder is either 4 or 6 or 8. So with that, it is going to show you what is the miles per gallon. So if I run it, so a file is created here, which is showing box plot. So it is showing three box plot. You can see the name of the box plot file title is mileage data. X-axis represents number of cylinders. Y-axis represents miles per gallon. Okay, and I can say if the number of cylinder is 4, I can say miles of gallon. You can see this is the box plot. Means the data is distributed like this. It is starting, let's say I am saying it is 21 or something like that, and it is going up to this one. Similarly, in the case of number of cylinder is 6, it is starting around I can say 18, and let's say it is going up to 21 or 22. Okay, but in the case of number of cylinder is 8, so it is starting with 14 and it is going up to 20, right? And here you can see there is a small circle. What this circle indicates? Can anybody guess what this circle indicates? It is a outlier, right? I told you it is going to show you it is an outlier. Any value which is 1.5 times of IQR deviating from quartile 1 or quartile 3, it is considered an outlier. So it is going to show you a outlier in this picture. Okay. Similarly, if you want a box plot with notch also, you can do it. So for that, let me create another script file. Okay, and let me take the same data which I am taking here, and let us save this as box plot 1.r. Okay, so I am taking the empty car data set, and you can, if you want to see the first 6 rows which I have displayed here, you can see it, right? Then I am creating a chart file with png function, that is file is equal to any name you can give. So I am giving the name as box plot with, let's say, notch. Okay, dot png or jpg, anything you want, you can mention it. So I am using the predefined box plot function. In the box plot function, I am writing mpg is a function of cyl. Okay, and data it should take from empty cars. If you want to mention x level, like you can mention x level as a number of cylinders, and let you want to mention y level is equal to miles per gallon, and main is equal to name of the chart. I can write mileage data, and let me write notch, which I told you it is a logical value which is true or false. So I'm writing true. Bar width is also a logical value, so I'm writing, let's say, true. And color I'm mentioning as, let's say, we can go for any 3 color. I'm writing green, let's say yellow, then let's say I'm writing next color is purple. Okay, so the next one I can mention names is equal to, also you can take a vector. So let's say I'm showing you high, medium, and low. Okay, the main idea is that notch is equal to true, right? So we are going to get a notched box plot. Then in order to save the file, we are writing dev. Okay. So I mentioned X level, Y level. I have given the chart name is mileage data, and notch and bar width is considered as true, and some colors and names I have mentioned. You can mention any color as per your choice. So if you execute it, okay, although I'm getting a warning message, some notches went outside the hinge box. Okay, let's see. So if I open it, so you can see it is showing you the same thing. It is showing you which a notched bar chart. Sorry, notch box plot. Box plot with notch feature, right? Because as notch is equal to true. So with high, medium, and low, so it is showing like in the previous case, it is showing with respect to what? The number of cylinder is either 4 or 6 or 8. But in this case, it is showing the same thing, but I represent it by a high, medium, and low. Like here you can see both charts are same, right? It looks same, but I have used a notch here, but there is no notch there. So instead of 4, it is showing here high. 6 case, it is showing medium. 8 case, it is showing low. Okay, so in this way, you can implement this visualization technique, that is box plot. Okay, so this is about the box plot. So till now we have started with pie chart. Then we have discussed about different variants of pie chart. Then we have discussed about the bar chart. Then we have discussed about box plot. So then we are going to learn another data visualization technique, that is called as histogram. Okay. So histogram is another technique. Mostly those people who are working in computer vision, pattern recognition, or image processing, they are frequently using histogram. So these are the parameters we are using. V is a vector. Main is the name of the chart. X level, you know. X level is if you want to mention anything in the X level, what is the meaning of X level? Let's say, for example, in the previous case, we consider X level as number of cylinders. You can also specify what is the X limit and Y limit. Okay, and also you can mention the breaks, which is used to mention the width of the each bar. You can divide it. You can mention color. You can mention the border. So let us do using R. Okay, so now let me save this blank file as histogram. Histogram. Okay, so I'm taking a vector. Let's say I'm taking a vector B. B is equal to, I'm taking the vector, let it be 9, 13, 21, 8, let's say 36, 22, 12, 41, 31, 33, and 19. Any order you can write. So in order to go for histogram, again you need a chart file. So I can write PNG file is equal to histogram dot PNG. Okay. And for histogram, we have a predefined function that is called as hist. So you can mention hist v comma x level is equal to, suppose x level I am mentioning as weight, color I am mentioning as any color I can mention. For example, let's say yellow color, and border I am mentioning as blue. And in order to save this file, I am writing dev. Okay, so if I run it, then in my document folder, another file is created, that is histogram. So you can see by default the y axis level is frequency. X level caption I have given already weight, and it is showing you the frequency. For example, if you the first look into the first one, so it is showing that the frequency is 2. Here the frequency is 2. Here the frequency is 2. Here the frequency is 1. Here the frequency is again 2. But in between, let's say 25 to 30. If you look into this data, there is no value in between 25 to 30. But there is some value from 30 to 35, whose frequency is 2, means two values are there. That is 31 and 33. Then between 35 to 40, also you have one value, that is 36. And beyond 40, you have a value, that is 41. So based upon how many values lies in a particular range, it is going to show you different bars. Okay. Now, if you want to specify the limits also, you can mention. For example, I'm taking the same and I'm creating, let's say, another file, which I am saving as histogram1.r. Histogram1.r. Okay. So in this case, let me rename the file as histogram limit. I'll show you, and breaks I'll show you. Breaks.png I'm writing. So in addition to these parameters, okay, which I mentioned, yellow color and blue color is the border. So I'm mentioning x limit is equal to, let's say, c of 0 to 45. So I'm saying that all the values, or I can take 5 to 45, something like that. Okay. And y limit I'm mentioning as either the frequency is 0 or the frequency is 2. So I'm writing 0, 2. Okay, 0, 2. Then if you want to mention breaks also, you can mention breaks is equal to, let me put enter here. Breaks is equal to, let it be, the number of breaks is, let it be 5. So let us see. If it is not coming, then we'll change the value. So if you execute it, errors in while limit, could not find the function while limit. Okay, while limit is c of, okay, while limit is equal to c of 2. Okay, now it is okay. Yes. So a file is created with the name histogram underscore limit underscore breaks. So you can see x-axis, we are taking the values from 0 to 45. Okay. Sorry, 5 to 45, not 0 to 45. And y limit I am taking 0 to 2. So for example, if you want to change the y limit to, let's say, 3, that also you can do. So if I reopen it, so now you can see it is showing up to 3. We have given maximum limit up to 3. So it is forcing the axis to put in the limit of 0 to 3 of y-axis, right? And in x-axis, it is taking the value 5 to 45. And number of breaks, it is giving 5. Okay. Okay, in this way, if you want more also you can do it. For example, if I want number of breaks is 10 also, I can specify, right? So if I open this one, you can see these many breaks are not, it is not possible, I think. That's why it is not showing any significant difference. But this x limit and y limit is more useful, because sometimes the graphs are coming arbitrarily and we want the values in a particular range. For that reason, we are using a specific limit. Okay, so this is all about histogram. Then we'll proceed for the next visualization technique, which is called as line graph. Okay, we have seen box plot. So sometimes we represent in line graph. For example, if you want some kind of series data, so line graph is more useful. So line graphs takes some parameter like b is a vector that is taking input, and type is considered as either p if you want to draw only the points. P indicates points. L indicates if you want to draw the lines, and O indicates both points and lines. That's why we are using O. And X level, Y level, you know, that is representing the captions of X axis and Y axis. Main is used to represent the title of any chart, and color is used to show any particular color. Okay, so let us implement line graph. A very simple line graph I'll tell you, then we'll go for the complex one. Okay, so let me close these two file and save this as line underscore graph. Okay, so now let me go to this line graph by taking a vector b is equal to, okay, vector b is equal to c of 7, 12, 28, 3 and 41. Okay, then I am creating a chart file. PNG file is equal to, let's say, line underscore chart dot jpg. Okay, I am creating a chart with name line underscore chart dot jpg. Then let's say I'm writing plot b. B is the vector and I want the type is O. O indicates, as I mentioned, I want to draw both points as well as the lines. And in order to save this one, I can save that is dev. So if I execute this code, if I go to my document folder, I have line chart. So here you can see the first value is 7, right? The next value is 12. Then next value is 28. Next it is coming to 3. Then it is going to 41. So in this way, you can show the different uh, sequence of values into a line chart. But if you want a colored one, for example, I'll take the same data. I'll create a new file and let me save this as line chart line graph 1.r, let's say. Okay. So I'm taking the data. Let me change the file name as line chart level underscore colored dot jpg. So in order to plot, I am not only plotting the vector and type, just I want to mention some color also. Let me write color is equal to red. X level also I am mentioning. X level is equal to month. Let's say Y level I am mentioning as rainfall or something like that. And title of the chart I am writing is rainfall chart. Okay. So if I execute it, and I will get a graph name is line chart, but here you can see it is showing a X level, it is showing you Y level, also it is representing the lines with the red color. Okay, but most of the times we compare our result with others result, right? So you need multiple chart, right? Multiple lines, not only one lines. Let's say you have proposed one algorithm and you are comparing with existing algorithms. So in that case, you have to draw multiple lines. So for that, let me create another line graph file. Say line graph 2.r. Let us take the same thing and we'll add one more. Suppose I am taking another vector t is equal to, let's say 14, 7, 6, 19 and 3. Okay, let me write lines. Okay, so in this case, I'll use plot. In addition to the plot, I'll use lines. I'll write t, type is equal to O, that indicates both point and lines is going to come. And color I want to mention for this line is blue color. Okay, so if you execute it, and you can see here, now the line chart is coming with the two lines. One is blue color line, another is the red color line. And x-axis represents your month, y-axis represent your rainfall. Okay, so in this way you can implement different line chart. You can add as many as lines. For example, sometimes we compare 5 different algorithms. So for each algorithm you have a line, right? So that comparison you can make using this chart, right? Line graph. So for each and every algorithm you have to draw one line. Okay, so the next chart we are going to discuss, that is called a scatter plot. It is also one of the very famous chart. So in scatter plot, in addition to all the things you know, only another additional parameter we are using, that is called as axis, which indicate both axes should be drawn on the plot, right? So mostly this scatter plot is more popular because sometimes we have a very large data set. We just want to know how they are distributed. Or if you want to perform clustering case also, you need to think about how to perform clustering using the scatter plot. Okay, by looking into scatter plot, then you can say how many clusters is required for a particular data set. In that way also it is helpful. So in order to implement scatter plot, let us create a script file and let me save this as scatter plot. Okay, so I am using empty car dataset again in this case. So I am writing input is equal to, input is going to take all the rows of the data set and two columns of the data set. One is W, I'm taking WT, another is JPG, MPG, sorry. One is empty cars, another is empty car data set. I'm taking all rows, but I'm taking two columns. One is WT, another is MPG. And I'm printing, if you want to know some rows about the data set, you know I am writing print head input. Okay. Now we'll see how to do scatter plot. So for that I am creating a chat file, png file is equal to scatter plot dot png. Okay. Then in order to save the file, obviously I'll write dev. In between I have to write the code for scatter plot. Okay. So scatter plot also uses the same function, that is plot, which we have seen earlier. So in x-axis, I want to plot input. Input is our data set, right? Where all rows are there. And two columns of the empty car data set. One is WT and another is MPG. So x is equal to input dollar $WT. What it indicates? In the input data set, it is going to take the column that is WT. If you open input, you can see there is two columns, right? WT and MPG. But I am taking only WT in x-axis. In y-axis, I want to take input dollar MPG, miles per gallon. Okay. And X level, I am mentioning as weight. Y level is mentioned as mileage. Okay. Mileage. And if you want to specify X limit and Y limit, that also you can mention. Let's say X limit is equal to, I am mentioning if I know about the data set, then only I can do. So for this data set, I am putting a random limit, let's say 2.5 and 5. If it is going beyond that one, then again you have to change. Y limit is equal to, let's say 15 to 30. Or you can go to this input data set and find the values and put a appropriate limit here. And name of the chart, I can mention something that is weight, let's say versus mileage. Okay, weight versus mileage. Okay, so this will give you scatter plot. So let us see here. So let us check in the document folder. There should be a file scatter. Yes. Okay, so here you can see scatter plot. So where it is showing that how the data is distributed. This is more important, right? So in comparison to weight and mileage, you can see different points. For example, if you want to make two cluster or three cluster, somebody can say that this is one cluster, this is another cluster. Again, this cluster can be classified as this one cluster, this is another cluster. This is one cluster, this is another cluster. So this type of analysis we can do once we perform the scatter plot. Okay, so if you want also scatter plot of a matrix also, that also you can do. Because here I am showing you with two variables. So sometimes we took more than two variables. And suppose you want to find the correlation between one variable versus the remaining ones. Okay, so there also you can use scatter plot. But there is a function used in that case that is called as pairs functions, which is create to matrix of scatter plots. Matrix of scatter plots means there is multiple scatter plots and they are arranged just like a matrix. So let us see how to do this one. So let me create a blank file and let me save as scatter plot one. Okay, so I am taking the same empty car data set and creating a PNG file. Let us rename that file as something like this, like scatter plot matrices. Okay, dot png or jpg you can write. So what I am going to do, I have to plot the matrix between, let's say, four variables. So in the data set, you should have four variables. So not only you have to take wt and mpg because these are two variables. So I have to take another two column. One is column disp is another column in this empty car data set, and cyl is another column in the data set, right? So I'll write the command as pairs wt plus mpg plus disp plus cyl. Okay, and data is equal to empty cars, or you can cite input. Okay, because input all the values are there, so no need to directly refer to the data set. And chart name you can mention something like scatter plot matrix and above. Okay, so if we run it, then it will create a matrix of scatter plot. So here you can see I am creating a matrix of scatter plot. I have taken WT, MPG, DISP and CYL. Okay, so this one is comparing WT with MPG. Another one is comparing WT with DISP. Another one is comparing the WT with CIL. Okay, similarly, the rest of the thing, the rest of the combination, MPG can be compared with WT, MPG can be compared with DISP or CYL. So it is showing all the varieties. So one variable with three others. So total we are four variables. So number of comparison is 4 into 4. So there are 16 you will get. Okay, but actually we cannot compare the same variable with same variable, right? WT cannot be compared with WT, right? So that's why it is showing you how many graphs. If you exclude 4, it is 12 graphs, but it is showing a 4 cross 4 matrix. Okay, so this is about the scatter plot. Then we'll see another interesting part that is called a skewness. Let me close these files. So you know skewness is an important measure because maybe in your data set all the values or maybe in either left side or right side, right? So we require a skewness function. So in order to see whether your data is in left skewed or right skewed, so what you will do, you can use skewness function. But skewness function is available under a package that is called as moments. So moments package, if it is there, then that's fine. So I can search here and check moments. So if it is not there, you have to install it. Okay. So now it is installing the moments package. Once the moments package is ready, I can write library moments. Okay. Then suppose I'm taking a data. Okay, I'm taking a vector 40, 41, let's say 42, 43, and 50. Some random data I'm taking. And I'm creating a chart file. Let's say file is equal to positive skew dot png. And I am going to print what is the skewness value of this vector x. And I also want to show you the histogram of x. Okay. So if you execute it, okay, I think it is created now. So positive skew. So you can see here. So it is showing you that in between 40 to 42, okay, like you can see in 40 to 42, three values are there. 43 is another value, but another value is very far away from that particular value. And if you calculate the skewness value here, the skewness value is 1.2099. Okay, skewness value is 1.2099, which indicates that it is a positive skewness. Similarly, somebody can go for checking that whether it is a zero skewness or not. Okay, sometimes you may get zero skewness, sometimes you get negative skewness also. So let us try with another value. For example, let me create another file. Okay, so okay, I'm creating another skewness file. In this case, I am getting, let's say I'm generating a vector x is equal to, without specifying a particular value, I'm going to use normal distribution. So I'm mentioning R norm 50, 10, 10. Okay, these are the parameters of normal distribution. And let's say I am giving the file name as zero skewness. Okay, because normal distribution case, you will get zero skewness and print skewness, histogram of bits and above. So in this case, if you execute it, okay, the problem, his text is there, zero skewness. Okay, now it is coming. We are getting the skewness is 0.2804. So that is close to zero. And if you want to visualize it, which I have given the name as zero skewness, so you can see all the values are equally distributed. Okay, so I am taking around 50 values here, right? 50 values with their mean values I am specifying. Okay, 10 10 indicates two different parameters, right? So in that case, you can see it is not 100% properly distributed, but almost it is distributed. These 50 values are distributed with you can say not it is not having that much skewness in comparison to the previous one, because sometimes data are left skewed or it may be right skewed. Okay, or we can say positive skew or negative skew. Similarly, you can take another data set, another set of data values. For example, I'm taking another file. For example, let me copy this value. Okay, I'm taking library moments only as the library. And instead of taking these values, suppose I'm taking the values like this 10, 11, 21, 22, 23, and let's say 25. Okay, you can see 10, 11 is one side and 21, 22, 23, 25 is another side. And if I calculate this value, skewness here, right? And I'm renaming the chart as a negative skew, because in this case you will get negative skew. So if I execute it, so you can see, right? You are getting a skewness is negative, you are getting minus 0.57. So most of the value is towards 20, is in between 20 to 25. But there is very less values in the range of 10 to 15. But when you go for actual data set, you will find a lot of values will be there either in the left part or in the right part. So such type of skewness data sets you have to identify, and once you identify, you can take a decision, right? That whether the data set is left skewed or right skewed, because based upon that your performance is going to vary. Okay, this I have also mentioned in the slide. Okay. So in this session, what we have discussed, we have started with why we need data visualization. What is the definition of visualization? What are the possible application? And I told you different types of analysis like univariate, multivariate, and bivariate analysis. And we have seen 7 different types of visualization technique and their variants. We started with pie chart, bar chart, then box plot, then histogram, line chart, then scatter plot, and skewness. So other parameters are also there. You can also explore based upon your requirement. Yeah, thank you everyone. If you have any question, you can ask.